Tamu Massif. Tamu Massif is an extinct submarine shield volcano in the northwest Pacific Ocean, with the characteristics of a hybrid between a mid-ocean ridge and a shield volcano. On 5 September 2013, researchers announced that it could be a single volcano, a claim which, if corroborated, would make Tamu Massif the largest known volcano on Earth. Tamu Massif is located in the Shatsky Rise, about 1600 km 990 mi east of Japan. The volcano covers an area of about 553,000 square kilometers, 214,000 sq mi. Its summit is about 1980 m 6,500 ft below the surface of the ocean, and its base extends to about 6.4 km 4.0 mi deep. The volcano is about 4,460 meters 14,620 ft tall. William Sager, a marine geophysicist from the Department of Earth and Atmospheric Sciences at the University of Houston, began studying the volcano in about 1993 at the Texas A&M College of Geosciences. According to Sager and his team, Tamu Massif is the biggest single shield volcano ever discovered on Earth. Other igneous features on the planet are larger, such as the Ontong Java Plateau, but it has not yet been determined if they are indeed just one volcano, or rather complexes of several volcanoes. Etymology. The name Tamu is taken from the initials of Texas A&M University. William Sager, a geology professor and one of the lead scientists studying the volcano, previously taught at Texas A&M. A massif, which means massive in French, is a large mountain or a section of the planet's crust that is demarcated by faults and flexures. Geology. The Tamu Massif was formed about 145 million years ago during the late Jurassic to early Cretaceous period over a relatively short period of time, a few million years, and then became extinct. Tamu Massif was formed during a single geologically brief eruptive period, which scientists had previously thought was impossible on Earth. If confirmed, the suggestion that it could be a single volcano would make the Tamu Massif the largest known volcano on Earth, dwarfing the current record holder, Puhahanu in the Hawaiian Islands. The main part of Tamu's rounded dome extends over an area of 450 km x 650 km 280 mi x 400 mi, totaling more than 292,500 km to 112,900 sq mi, many times larger than Mauna Loa, which has an area of 5,000 km to 1,900 sq mi. The entire mass of Tamu consists of basalt. Its slopes are very gradual, ranging from less than half a degree to 1 degree near its summit. The Shatsky Rise oceanic plateau is comparable in size to California or Japan, but Tamu Massif, which is the plateau's oldest and largest edifice, is comparable in size to New Mexico or Britain and Ireland together. A study in 2016 found that Tamu Massif likely encompassed the entire Shatsky Rise, meaning that Tamu Massif has an area of about 533,000 square kilometers, 206,000 sq mi, surpassing Olympus Mons in surface area, though it has not yet been determined which of the two volcanoes has a greater mass. Using magnetic lineations, researchers discovered that there are 3 bathymetric highs and a low ridge, a topography that would imply 3 separate volcanoes, but the plume head model indicates a single massive volcano. Based on multi-channel seismic profiles and rock samples from Integrated Ocean Drilling Program IOD core sites, Tamu Massif appears to be a single massive volcano made of lava flows that emanated from the volcano's center and formed its shield shape. However, the profiles have large gaps in them, leaving open the possibility that it may represent the activity. A subsequent study in 2016 found that the massif was likely generated by a single volcano. In 2015, researchers found that the volcano's structure bore patterns of magnetic striping on either side, indicating that the volcano is likely a hybrid of a mid-ocean ridge and a shield volcano. Geologic data also indicated that Tamu Massif formed at the junction of 3 mid-ocean ridges, which was a highly unusual occurrence. A study found that the Moho line, the boundary between the Earth's crust and mantle, extends more than 30 kilometers 19 mi beneath the base of Tamu Massif, meaning that the volcano is unlikely to ever erupt again, since magma is presumably unable to penetrate a barrier that thick.